Hello my dear students, I warmly welcome you to SIA's digital classes. In this lecture, we are going to discuss about the application problem of the criterion for a power I is equal to a power z. This question has been asked in the short answers in the previous examination. For the upcoming examination purpose also, these types of questions are very important. Okay, so let's see what is the question. Let capital G be a group and small a be an element in capital G of order n. If a power k is equal to small e, then prove that n divides k. Okay, so given that capital G is a group and small a belongs to capital G with order finite order, a power n is equal to small e. Okay, randomly we can take this value trivially. So and if a power k is equal to small e, okay, again the same element, we have small a has order n. In the problem what he is asking, if the same element has another order small k, then prove that the two order values will divide both of them. Okay, so n divides k. So if a power k is equal to small e, then we have to prove that then n divides k. Then we have to prove that n divides k. To prove this problem, okay, we are going to apply the criterion for a power I is equal to a power j. That is the second condition. In the criterion for a power I is equal to a power j, we are going to use the second condition. So therefore, by using criterion for a power I is equal to a power j, okay, so we have, so I wrote here the statement of the criterion for a power I is equal to a power j, second statement. Now with the help of this statement, we are going to prove this problem. Okay, so here a power I is equal to a power j, we have if a has finite order, that is a power n is equal to e, and that a generates a cyclic group. Okay, so and if a power I is equal to a power j, then n divides I minus j. So therefore, since we have a power k is equal to small e, this a power k is equal to small e, we can also write a power k is equal to a power 0, since the identity element you can write in the cyclic group. So therefore, by using given condition, we can write a power n is equal to a power k if and only if n divides k minus 0. So that implies a power n is equal to a power k if and only if n divides k. So therefore, if a power k is equal to e, then small n divides k. Okay, this is the problem. Here in place of I we have k, in place of j 0. Okay, so in place of n we have n only. That's why simply you can apply n divides I minus j, that implies n divides k minus 0. So that implies you can write n divides k, where n and k are the orders of a only. N is the one order and k is the one order, but both of them divides mutually. So this is the problem. In this format, if you get any problem based on this divisible condition, you have to apply the criterion for a power I is equal to a power j whenever order of a is finite. If they ask order of a is infinite, then you have to use the first condition. Okay, so I hope you understood this problem very well. In the next lecture, we'll come up another problem. So practice well. prepare well. So until bye, thank you.